Hi, this is the second part of the front-end scaling video series. If you missed the first part, please watch it before we continue. In the previous part, we discussed different approaches to front-end architecture, monolithic architecture, micro-frontends, and modular monolith. In this part, we'll discuss mono and poly repositories, and after that, look at a couple examples to consolidate our knowledge. Let's begin. Okay, now when we understand the difference between the use cases of different architectures, we can go one level up and gonna talk about mono and poly repositories. Before we start, let's clarify the difference between these two approaches. Mono-repository is a single repository containing multiple projects or components, simplifying dependency management and improving consistency across the codebase. Multi-repositories are collections of separate repositories, each containing a single project or component, providing flexibility and autonomy to individual teams or projects. I have seen some beginner developers confuse mono-repository and monolith. They are not equal. Monolith is a single application which deployed as a single unit. Mono-repository is a version control repository management strategy where multiple projects or components are stored within a single repository. A monolithic application cannot include modules or parts. Mono-repository must include more than one application. Let's look at 3 examples. In the first case, the mono-repository includes 2 applications, front-end and backend apps. The second includes 2 front-end apps and a shared library, which is probably used by both front-end applications. In the third scenario, the mono-repository includes 2 microservices and shared code. Other combinations are also possible. Before we get started, I also want to say what we will not cover in this video. We will not cover specific mono-repository management tools like NX, Lerna, or TurboRepo. You might ask, why? Typically, you are rarely asked about specific tools in a job interview. This is because companies are interested in developers with system design experience, not experience with specific tools. Tools becomes outdated very quickly. One technology is very popular today, but things can change tomorrow. This won't be a problem for you if you understand the key concepts. As a summary, invest your time in learning the core concepts, not the tools. Mono-repositories for monolithic and modular monolithic do not do much sense, because mono-repository must contain at least 2 projects. Of course, we can have 2 monolithic apps in the mono-repository, as we saw before. In this case, you may find a lot of information on why mono-repositories are bad or good. In this video, I wanted to look at the mono-repositories in the context of what we discussed before. Let's look at the micro-frontends and when it makes sense to keep them in one repository. Poly repositories for micro-frontends look like a very reasonable option. We have separate development, testing, and deployment processes, so it's quite logical to keep micro-frontends in separated repositories. So why we should consider a mono-repository as an alternative? The first reason is high visibility. If you're working on a micro-frontend that call other micro-frontends, you can look at the code, understand how it works, and find out if bugs are from your code or another team's micro-frontend. The next reason is code sharing. If common models, shared libraries, and helper code are all stored in a single repository, teams can share them among many micro-frontends. Standardization. With mono-repositories, it is easier to standardize code and tooling across the teams. You can create policies that limit access to specific branches, enforce naming guidelines, include code reviewers, and enforce best practices. And discoverability. A mono-repository offers a single view of the whole code, screen all branches, and keep track of modifications much more easily in mono-repository than in poly repositories. It sounds good, but such an approach also has some problems. Fragile modules. Changing the shared code can affect many components of the application. Merge conflicts. When multiple engineers are working on a large codebase, this can lead to frequent merge conflicts. Security concerns. Poly repositories allows you to separate access rights for developers. Each team has access only to its part. With mono repositories, it's not possible, or at least not very easy. Large size. Usually, developers do not need to load the all micro-frontends. Some types of virtual file systems allow part of the code to be present locally. Slow indexing, searching, and discovery. Since no developer will have all of the code in a searchable state, there must be the ability to search the entire codebase. We discussed the pros and cons of mono-repositories. Next, let's look at the use cases when mono-repository probably would be useful. Tightly integrated frontends. If your micro-frontends are tightly integrated and share dependencies, the mono-repo can provide a centralized place to manage common codes, libraries, and dependencies. This can simplify development and ensure consistency across micro-frontends. Sharing code is very important. Mono-repository makes it easy to share and reuse code between micro-frontends because all components are in the same codebase. Application must be released together. If monoliths should be released together, they should be in the same repo, because you can easily manage projects with different release schedules from the same repo if you need to. Let's look at cases when we shouldn't use mono-repositories for micro-frontends. If we have decoupled and independent frontends. If micro-frontends are designed to be developed independently by different teams, Poly-repositories provide greater autonomy and flexibility. Each micro-frontend can have its repository, allowing teams to autonomously manage their codebase. If we have a large number and services of a large size, Poly-repos can scale well with the increasing number of micro-frontends, as each micro-frontend has its repository. This helps manage complexity and avoid bottlenecks in the development and deployment processes. You may argue here that many big tech companies implemented mono-repositories and keep many applications and libraries in it. The most obvious example is Google. However, the point is, we probably do not have as many resources as Google has. Mono-repositories are an instrument that may facilitate the development process, but they require additional resources to maintain. If we have these resources, we can ignore this warning. Let's summarize. We can keep micro-frontends in a single repository as long as we continue to benefit from it. Shared code, easy of development, etc. When the mono-repository becomes inconvenient due to its size or security concerns, we can easily put the services in separate repositories. Another interesting case I want to discuss is the development of full-stack teams. Having a full-stack team is a very common case for small or even middle-sized companies. For small projects, it doesn't make sense to have many specialized developers. It's more reasonable to have a team of full-stack developers who can work simultaneously on the front-end and back-end parts of the application. The trendy solution for such teams is to have a back-end app on the Node.js. For which cases should we consider a mono-repository? If front-end and back-end applications represent a single entity, we can put them in a single repo to ease the development process by increasing visibility and discoverability. When a developer is working on a project, they can easily run the entire project locally. It's mostly suitable for small or medium-sized projects. As the project grows, it becomes difficult to keep the details of both applications in mind. When we are talking about full-stack projects in the mono-repo, it is worth mentioning tRPC. tRPC, or TypeScript RPC, is one implementation of RPC designed for TypeScript mono-repos. In other words, if we have TypeScript on both the client and the server side, we definitely should consider tRPC as an option for client-server communications. tRPC allows to facilitate client-server interactions. Front-end devs do not need to think about implementation details as we do it with REST, which verb is used for operation, how to define URL, etc. We simply call the functions and tRPC do the rest of the work. I had the whole video about the tRPC and other network protocols. You may see the link to it somewhere here, and I will also add it to the description. The last thing that we will discuss about mono-repositories is versioning. When we have multiple applications in one repository, what version should we use? There are three different approaches for versioning in mono-repos. The first one is semantic release versioning. This is a fully automated versioning method. Semantic release automates the entire package release workflow, including determining the next version number, creating release notes, and publishing the package. The next one is manual versioning. In manual versioning, the developer and maintainers are responsible for changing versions. This happens either entirely manually or by using a tool to determine the next version. But in either case, the choice of the next version rests with the developers. And the last option, global versioning. All packages and services have the same version. One change in one of them increases the version of all other packages and services in the codebase. This approach has many advantages and it's very popular, but can be a bit complicated. I believe that the first two approaches are clear. The only difference between them is how exactly we install the new version. But the logic of the approaches is the same. Let's discuss the third one, global versioning. Global versioning implies that all projects in the mono-repository have the same version. Using one global version for all applications in a mono-repository may seem convenient at first glance, but has its compromises. Calculating and fetching the global version. The global version source might change while a pipeline is in the middle of its work. It can be fixed if commit all the version changes locally using a tool like Learner. Scaling. When we upgrade any service or package, we have to upgrade everyone in the repo. This is very expensive for huge projects. In the picture, we can see how it works. We made changes in one project, but we have to update versions of all projects in the repository. The problem becomes more serious with the increasing number of apps in the repository. Okay, let's do some practice. Imagine that during the interview you have to build an architecture for the admin dashboard. In this panel, different clients can register and use our services. Each service is logically separated from the others. One client can use one or more services. In the picture, we see that our example app has 4 different services: users, metrics, budget, and groups. As usual, before making some decisions, we need to understand the requirements and resources that we have. In the real interview, we discuss it with a real interviewer. But now let's try to imagine for such an application might look like. Services are not coupled with each other. They have a separated deployment processes. They may share some common code, but they do not communicate with each other. Each service is maintained by a separated team. Each service uses a single backend application. However, a single backend application can be used by multiple services. The use of different technology stacks is not required. Since all applications do not have any specific requirements, we can build them based on the same technology stack to improve interchangeability between developers of different services. The basic navigation elements, menus, headers, and footers are the same for all services. They should always be visible and common to all services. As we discussed previously, we start with the most simple solution, monolithic architecture. However, we start to realize soon that the monolithic architecture is not the best idea. The application consists of different services. Each service is managed by a separate team. Deployment of services does not depend on each other. Monolithic architecture is not scalable enough for medium and large projects. Even in the current stage, application doesn't look small, and we expect that existing services will grow and new one will be added. Okay, monolithic architecture is not a good solution. The next possible option is a modular monolithic architecture. This solution is much better. Modular monolith can scale. The growth of the application and team size is not a critical issue for us. Separating of responsibilities. By dividing the application into different modules, we allow different teams to work only on their part. We can go further and stick to micro-frontends. The main question here, how much is independent of our services? If we decided to move forward with micro-frontends, we create additional challenges in providing code sharing, communication between modules, and CI/CD processes. If high independence of modules is important, we want to deploy them separately, we would stick with micro-frontends. If not, we can stay on modular monolith. In case when we decide to go with micro-frontends, we also need to decide how we will organize code in repositories. Will we use mono-repository or multiple repositories? If we go with mono-repository, we will get easy code sharing, easy of making changes to multiple services, and good code visibility. But mono-repositories requires more resources to orchestrate. So the question is, are these advantages crucial in our case? The answer is no, not really. Teams work on modules mostly independently. Moreover, a mono-repository requires additional resources that are not worth it. Let's look at the whole picture. It consists of 5 modules: users, budget, metrics, groups, and settings, and the application shell. The core team will work on the application shell and settings modules. Other modules are distributed across different teams. Let's move to the next example, the TODO application. I use the TODO application here as an example of a simple web application. Instead of TODO application, we can use as an example any small web application with one main feature. I hope you're all familiar with the features of TODO applications. It allows users to create, update, delete, and make complete tasks. We do not have special requirements here. The application is very simple. Not many developers are working on it. We can imagine that it's a team consisting of 2 or 3 developers. Again, we will start with a monolithic architecture. What are the reasons to stay with it? The whole team works on all parts of the application. Separating the teams into modules doesn't make much sense since we have a small application and a small team. It will only add additional complexity. If we decide to go with a monolith, it will give us easy of development. We do not need to run multiple apps and find ways to establish connection between them. Instead, we have everything in one place. Easy testing and debugging. We can run the application as a whole and easily track the whole stack trace of the bug. It is also easy to test since we see the whole picture. Consistent UI. We do not expect any surprises in production, since our application locally looks the same as it will look in the production. It's easy to start and cheap. Monolithic architecture is a good start for small applications when we are not sure about commercial success and do not want to invest too much resources in the architecture. It looks good, but there is no silver bullet, right? Let's look at why monolithic architecture might be a bad choice in our case. We have more than one model. It looks like we have a very limited set of features, but in reality, even such simple applications may have multiple modules. For example, the authentication model and settings model. The next problem is a manifestation of Peter Pan syndrome. The Peter Pan syndrome refers to the tendency of software application to remain stuck in outdated or immature states. In other words, the team believes that application will never grow, therefore they shouldn't care about scaling. When choosing the architecture for the application, we should think not only about the current state of the application, but about future development on it. The next logical step is a modular monolithic architecture. What it may give us. Advantages of monolithic architecture. The only exception here is that a modular monolith requires more resources to build the architecture. Clear boundaries between modules. The initial establishment of these boundaries takes time, but it greatly improves the further development of the application. And readiness for growth. We make our application ready for further scaling and splitting into micro-frontends if required in the future. Should we implement modular monolith? It depends on our plans for the future. If the design of our application is finalized and we do not expect a lot of big changes in the future, we can stick with a monolith. If it's just a first iteration of the application and we have plans to make it bigger and what is important, we have time and resources, it makes sense to start with a modular monolithic architecture. The last option is micro-frontends. The application is a good example of when micro-frontends make things too complicated without bringing benefits. The next question is, should we use mono-repositories or not? Since we have a single application, we simply keep the code of the front-end application in a single repo. But we also have a back-end application. For such applications, it's quite normal to use the same technology stack on the front-end and back-end sides to make development cheaper. We also may assume that both front-end and back-end apps use TypeScript. And for the sake of lower costs, we have a team that consists of 2 or 3 full-stack developers. For such case, I would be moving forward with a mono-repository. Projects are tightly coupled and probably will have a single development cycle. It also gives us high discoverability of the code, which make development faster. Additionally, we can apply tRPC to make communication between front-end and back-end parts easier. We are almost done here. In conclusion, I will provide a framework which helps you to determine the appropriate architecture for the project. On the left side, we see a scale of project and team size. They are going here together because usually with the growth of the application, the team also grows as well. We start with a monolithic and mono-repository for all applications. Mono-repository here means that we have a single repo. If the answer to one or more questions that I listed here is yes, we can consider jumping to the next level. The next level is a modular monolith. Here is a list of control questions. If one or more of them is answered by yes, we can think about separating our application on micro-frontends. With micro-frontends, we need to know, should we stick with the mono-repository or it would be better to switch to the multiple repositories. Look at the list of the questions. By answering them, you will understand what solution is more suitable in your case. That's all for today. If you found this video useful, please don't forget to click the like button and subscribe to the channel. Thank you for watching and see you next time. Bye!